so we're back with still in circles. Remember, so far we have for polar, circles is r equals some number. It could be a positive or negative number. That circle will be centered at the pole, so we'll take the whole unit circle to graph it. Now we're going to look at circles. To start out with, the circles are going to have the form r equals a, so just some number a, cosine theta. So this is going to be a circle. Cosine, remember, refers to the x values. So that means it's going to be located on the x-axis. So it's either going to be right of the pole or left of the pole. So either right or left of the pole. Okay, so if you see this cosine theta with a number, it's going to be a circle. And then because cosine relates to x values, it's either going to be on the right of the pole. So this is an example of right of the pole. The circle is literally on the right of the pole. Or it's going to be on the left of the pole. So how do you tell that? So this value a here. First off, the diameter, so be careful for the last one, but the diameter of the circle is going to be what that a value is. Now it is going to have to be the absolute value. For some reason it's negative. So if you want to get the radius of that circle, you would have to do the absolute value of a divided by 2. And a lot of times we just talk about the radius, so just keep an eye on that going back and forth. Just be careful with what they're asking for. So to tell if it's going right or left, so if your a value is a positive number, then that means it's going to be on the right of the pole. If that a value is a negative number, then your circle is going to be located on the left of the pole. Okay, so cosine tells you left or right, positive tells you right, negative tells you left, and whatever this absolute value, this a value is, that tells you what the diameter of the circle is. So when we go to graph these, if we know it's on the right of the pole, we're going to count over the diameter spaces, and then we can just draw in our circle. Okay, so looking at some examples for this, the first one we have is r equals -2 cosine theta. And I'm going to write all this information on all these problems because some of the work you'll be doing, they don't even ask you to graph it. They just say, like, write everything out. So because we see that it's a number in cosine, we know that this has to be a circle. We know because this is -2 that the diameter of this circle is 2. Because this is a negative and it's cosine, this is going to be located on the left of the pole. And then, if you look at our last graphs, and I forgot to mention this on this, they only take up half a unit circle. They don't go in these other two quadrants. So it only takes out pi radians to trace these types of circles. So just pi to trace instead of 2 pi. Okay? So let me try to draw this. So first off, you're going to have one point at your pole. Okay. The other point, you're going to move over the diameter. So we're going to move a diameter of 2, and because it said left of the pole, we're going to move 2 spaces to the left. So those are going to be the 2 dots I have to work with. Now from here, you're just sketching the circle. So yes, but this should just be a circular shape here. And just make sure, like if you were doing this on a test or something, that I can just see these 2 dots here. That would just be the main thing. So that should be a circular shape. It doesn't look circular, but you can just pretend like it is. So next one we have is r equals 4 cosine theta. So we know that this is going to be a circle. The reason we know it's going to be a circle is because we have a number and we have cosine. Okay. The diameter of this circle is going to be the a value, so the diameter is going to be 4. Alright, left or right of the pole. So see how this is cosine, so it means it has to be left or right. It's a positive number, so it's going to go on the right of the pole. And because this circle is not centered at the pole, it's going to be on one side or the other. It's only going to take half of the circle to trace, so it's only going to take pi to trace. Alright, so let's see if we can sketch this. So we're going to have one point always at the pole for this. The other one is going to go at the diameter of 4, and it says we're moving to the right. So the other one would be right here. Okay. And then you're just going to do your best to draw in a circle. That's a little bit better. But you just make sure you can see your points there. So you should have a point at the origin and a point to the right of 4, and then you can just draw your circle. So far we have 2 types of circles. We have, let's get back on here. We have r equals k, so r equals a number that will be centered at the pole. It will take the whole unit circle to graph that. Next we have r equals a cosine theta, which is either going to be on the right or the left of the pole. It only takes half the circle. So now, our last equation type for circles is if we have r equals a sine theta. So we know that sine goes with the y values. So that means this is either going to be above or below the pole. Instead of left or right, it's going to be above or below, because that would be moving up or down for the y values. So, once again, this a, the absolute value of that a is your diameter. Just like with a, r equals a cosine theta. If your a is positive, then it's going to be above the pole. Whereas if your a is negative, we're going to be going below the pole. So above the pole would look like this. You would go count up your diameter and draw your circle. Below the pole would look like this. Just like with the a cosine theta on the last problem, it only took out half of the circle to draw because you're only either going to be in the top 2 quadrants or the bottom 2. So this will only take pi radians to trace. Alright, so let's look at a few examples. So the first example that we have is r equals 2.5 sine theta. So let's write down some information that we know. That 2.5 out front tells us well, first off, we know because it's 2.5 in sine, we know it's going to be a circle as the shape. The 2.5 out front tells us the diameter. Alright, we know because this is sine and this is positive that it's going to have to be above the pole. And then because it's above the pole, it's only going to take the 2 top quadrants, so it's only going to take pi to trace. Okay, so let's see what we can do here. So if we put a point at the pole, and then we said it's going to be above the pole, so we're going to move up, and we're going to move up the diameter. So 1, 2, we're going to be at 2.5. Then we're going to do our best to draw in a circle. And once again, hopefully you've been watching this whole video and you are listening to the sound, but it should actually be a circular shape there and not look like that. But you're just drawing in your circle there. Okay. Once again, I apologize, it's really hard to do this with the mouse. Okay, so our next example is r equals negative 4 sine theta. So because we just have a number and we have sine, we know the shape is going to be a circle. Once again, we only worked with circles so far. That negative 4 tells us our diameter is going to be 4. Because we have a negative and we have sine, it's going to be below the pole. Then, because we have, it's going to be below the pole, we're only going to be taking up 2 quadrants. So, it's going to only take pi to trace. Now, just a little note about that. When I drew this circle here, this really should not come into these quadrants here. It should just stay up here. So, just keep that in mind. Okay, so we have a point at the pole, and then we have a diameter of 4, and it says we're moving below the pole. So we're going to count down 4 spaces, and then I'm going to try to be more careful this time. So it really should just stick into this quadrant here. There we go, that's a little bit better. So you just have your 2 points here, and your circle was below the pole. Okay. So that is circles. Something just to note, whenever you're working with the 4 sine theta or negative 4 sine theta, this number right here is your diameter. But if I said r equals 4, then now this 4 represents the radius is 4. So that is one of the things that people get tricked up on the most. So just be kind of careful with that. So 4, r equals 4 is the radius, but if it has the sine or cosine with it, then that 4 represents your diameter. Okay. Alright, so circles was our first shape. Our next shape we're going to be doing are rose curves. And I think I'm going to save rose curves for the last video.